Preparing for a site reliability engineering at Snowflake interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does reliability mean for a platform like Snowflake? For Snowflake, reliability means customers can load, query, and manage data consistently, securely, and within expected performance boundaries. I would measure availability, request success, latency, durability, and data correctness rather than treating uptime as the only goal. Because storage, compute, and platform services interact, I would define customer-oriented SLOs for each critical path. Reliability also includes graceful degradation, transparent incident communication, and preventing one customer's workload from affecting another. While answering, focus on availability, durability, correctness, latency, isolation, customer impact, measurable SLOs, and the trade-off between reliability investment, engineering velocity, and cloud operating cost. Question 2. How would you design SLOs for a Snowflake data service? I would begin with important customer journeys, such as submitting a query, retrieving results, loading data, or creating a warehouse. For each journey, I would define an SLI that reflects success from the customer's perspective, then set an SLO using historical performance and business expectations. I would separate availability from latency and data correctness. Finally, I would establish an error budget, review it regularly, and use burn rates to guide release or reliability decisions. Make sure to cover user journeys, SLIs, error budgets, availability and latency targets, percentile selection, exclusions, dependency boundaries, regional differences, and how SLOs drive prioritization. Question 3. Explain the difference between SLIs, SLOs, and SLAs. An SLI is the measured indicator, such as the percentage of query requests completing successfully within a latency threshold. An SLO is the internal target for that indicator, perhaps 99.9% monthly success. An SLA is the customer-facing commitment, usually with contractual remedies or credits. I would keep SLOs stricter than SLAs so teams have operating room. The gap between 100% and the SLO creates an error budget that supports controlled innovation. In your answer, distinguish measurement from internal objective and external commitment, give a Snowflake-relevant example, and explain error budgets, reporting, and consequences when targets are missed. Question 4. A query latency SLO is burning rapidly. How would you investigate? First, I would verify that the alert reflects a real customer-facing regression rather than instrumentation failure. Then I would segment latency by region, cloud, account, warehouse size, query pattern, and request stage. I would correlate the change with deployments, dependency health, capacity, and workload shifts. In parallel, I would communicate impact and apply a safe mitigation, such as rollback or capacity adjustment. After stabilization, I would document the causal chain and add targeted detection. Be sure to mention confirming the signal, segmenting by region, account, warehouse, query type, and dependency, checking recent changes, identifying customer impact, mitigating quickly, and preserving evidence. Question 5. How would you handle a production incident affecting multiple Snowflake customers? I would declare the incident at the appropriate severity, establish an incident commander, and assign operations, communications, and subject matter roles. I would quantify affected customers, regions, operations, and start time, then prioritize containment over proving the root cause immediately. Possible actions include rollback, traffic reduction, failover, or disabling a risky feature. I would provide regular, factual updates, maintain a timeline, and finish with a blameless review containing owners and deadlines. Focus on incident command, severity assessment, customer impact, role clarity, mitigation before diagnosis, status communication, escalation, change control, and a blameless post-incident review. Question 6. What is a good incident postmortem, and what makes it useful? A useful postmortem explains what customers experienced, when each event occurred, how detection and response worked, and why safeguards failed. I avoid assigning personal blame and instead examine system design, assumptions, process, and organizational conditions. Actions should be specific, prioritized, owned, and dated. Examples include improving a rollout guard, adding a dependency timeout, or correcting an alert. I would later verify that those actions reduced recurrence risk rather than merely closing tickets. Mention a precise timeline, customer and business impact, contributing conditions, detection and response evaluation, blameless language, corrective actions, ownership, deadlines, and verification of effectiveness. Question 7. How would you make a distributed service resilient to dependency failures? I would first classify the dependency and define what the service can safely do without it. Every call needs a bounded timeout, and retries should be limited, exponential, jittered, and reserved for transient, idempotent failures. Circuit breakers and bulkheads prevent one dependency from exhausting shared resources. I would expose meaningful degraded behavior where possible, instrument dependency, latency and error rates, and test failure modes. The design should prevent retries from amplifying an outage. Cover timeouts, bounded retries, exponential backoff with jitter, circuit breakers, bulkheads, idempotency, fallback behavior, dependency budgets, observability, and avoiding retry storms. Question 8. How would you prevent a noisy customer workload from affecting other tenants? I would combine logical and resource isolation with admission control and fair scheduling. Workloads should have bounded concurrency, memory, and queue usage, while separate compute resources or pools limit blast radius. Back pressure is preferable to accepting unlimited work that eventually fails unpredictably. I would monitor saturation and tail latency by tenant and workload class, then apply quotas or workload management policies. The goal is not identical treatment, but predictable service for every customer. In your answer, discuss tenant isolation, workload management, quotas, admission control, resource pools, fair scheduling, back pressure, monitoring, and preserving predictable customer experience. Question 9. What is the difference between horizontal and vertical scaling, and when would you use each? Vertical scaling increases the capacity of one resource, while horizontal scaling adds more resources and distributes work. I prefer horizontal scaling for independent requests because it improves elasticity and failure isolation. Vertical scaling can help when a workload needs larger memory, faster local processing, or cannot partition efficiently. In a separated compute architecture, warehouses can often scale independently from storage and control services. I would validate the bottleneck first, because scaling the wrong layer only increases cost. Explain adding instances versus increasing instance capacity, discuss statefulness, bottlenecks, cost, elasticity, failure domains, workload characteristics, and how Snowflake's separated compute model affects the choice. Question 10. How would you design an effective monitoring and alerting strategy? I would start with customer outcomes, successful requests, latency, freshness, correctness, and capacity headroom. Then I would add the golden signals, traffic, errors, latency, and saturation, across service and dependency boundaries. Alerts should be actionable, tied to slow impact, and routed by severity. Burn rate alerts are useful for catching both fast and slow budget consumption. Dashboards should support investigation, not just display metrics. I would regularly remove noisy alerts and validate coverage through exercises. Be sure to cover customer-centric metrics, golden signals, dashboards, actionable thresholds, severity, burn rate alerts, dependency visibility, cardinality control, and reducing alert fatigue. Question 11. How would you safely deploy a change to a critical production service? I would make the change small, test it automatically, and deploy progressively through environments and a limited production cohort. A canary should be evaluated against predefined availability, latency, correctness, and resource signals, with customer segmentation where relevant. Feature flags can separate code deployment from activation. Rollback must be tested and fast, not merely documented. I would pause expansion if error, budget burn, or business metrics deteriorate, then investigate before continuing. Discuss automated tests, small changes, progressive delivery, canaries, feature flags, health criteria, rollback readiness, observability, approval policy, and using the error budget to control release pace. Question 12. What would you look for when reviewing a disaster recovery plan? I would verify that the plan defines realistic RPO and RTO targets for each critical service and maps all dependencies, including identity, networking, metadata, storage, and external providers. Backups or replication must be protected, restorable, and integrity checked. I would examine regional failure assumptions, failover automation, permissions, and customer communication procedures. Most importantly, I would run game days and restoration tests. A recovery plan that has never been exercised is only a hypothesis. Focus on recovery point and recovery time objectives, dependency mapping, regional failure assumptions, backups, replication, data integrity, automation, access controls, communication, and regular restoration testing. Question 13. How would you investigate intermittent errors that are difficult to reproduce? Intermittent failures require preserving context, so I would use correlation IDs across services and collect structured logs, traces, and relevant request metadata. I would segment failures by region, host, tenant, software version, dependency, and time window to identify hidden concentration. I would compare successful and failed requests, check recent changes, and avoid relying only on averages. If necessary, I would increase targeted sampling or reproduce under controlled load while protecting production. Mention correlation IDs, structured logs, distributed traces, high cardinality dimensions, time window analysis, sampling strategy, recent changes, dependency correlation, and controlled reproduction. Question 14. What is your approach to capacity planning for a cloud data platform? I would forecast demand using historical usage, growth trends, seasonality, launches, and customer behavior, while separating steady state from burst capacity. I would track saturation, queue depth, latency, throttling, storage growth, and scaling time across every critical layer. Capacity targets should include failure headroom and respect cloud quotas and dependency limits. I would compare forecasts with actuals, review cost implications, and test whether autoscaling responds quickly enough during realistic workload spikes. Cover demand forecasting, workload seasonality, saturation indicators, queuing, headroom, scaling time, cost, quota constraints, dependency capacity, and validating forecasts against actual usage. Question 15. How do you balance reliability, feature velocity, and cloud cost? I treat reliability and cost as product constraints, not obstacles to delivery. Error budgets provide an objective signal. When burn is high, I would slow risky releases and prioritize remediation. When performance is healthy, controlled innovation is reasonable. For cost, I would measure resource efficiency without weakening isolation or SLOs. I favor reversible experiments, progressive rollout, and explicit trade-offs. A cheaper design that increases customer incidence is not truly efficient because it shifts cost downstream. In your answer, explain error budgets, risk-based prioritization, reversible experiments, cost observability, capacity efficiency, customer value, and when reliability work should supersede feature delivery. Question 16. How would you test a distributed system's failure modes? I would begin with a risk-based failure matrix covering dependency errors, network partitions, delayed responses, storage unavailability, exhausted resources, bad deployments, and regional loss. Each experiment would have a hypothesis, safety guardrails, limited blast radius, abort criteria, and expected customer behavior. I would observe both technical and slow outcomes, then verify recovery and rollback. Game days and controlled fault injection reveal weaknesses that ordinary unit tests and happy path integration tests miss. Discuss failure hypotheses, dependency outages, latency injection, resource exhaustion, regional disruption, fault isolation, controlled blast radius, observability, rollback, and learning from chaos exercises. Question 17. What makes an operational runbook effective? An effective runbook lets an engineer act safely under pressure. It should describe symptoms, likely scopes, required permissions, dashboards, diagnostic steps, decision points, mitigations, escalation contacts, and rollback procedures. Instructions must be concrete and ordered, with warnings around irreversible actions. I would include customer communication guidance and links to related incidents. Runbooks should be tested during drills, updated after incidents, and automated where repetition or human error creates unnecessary risk. Mention clear symptoms, scope assessment, prerequisite access, diagnostic commands or dashboards, decision points, safe mitigations, escalation paths, rollback steps, communication templates, and regular validation. Question 18. How would you improve the reliability of an on-call rotation? I would first measure pages per shift, false positives, response time, duration, escalation frequency, and after-hours load. Then I would eliminate non-actionable alerts, improve routing, automate common remediations, and strengthen runbooks. Ownership and escalation must be explicit, with reliable handoffs and backup coverage. I would review recurring incidents through a blameless process and invest in permanent fixes. Sustainable on-call is a reliability control because fatigued responders make slower, riskier decisions. Focus on sustainable workload, clear escalation, alert quality, service ownership, handoffs, runbooks, automation, incident reviews, fatigue prevention, and measuring interruptions and response effectiveness. Question 19. Tell me about a time you improved reliability without being asked. In one role, I noticed repeated deployment-related alerts that consumed several hours each week but rarely represented real customer impact. I analyzed the incidents, identified an overly sensitive threshold and a missing canary check, then proposed a staged fix to the service owner. We tuned the alert, added validation before rollout, and documented the decision. False pages fell by roughly 60%, while detection of genuine failures improved. I also scheduled a follow-up review to confirm the change held. Prepare a concise star example showing baseline risk, your initiative, technical intervention, measurable outcome, stakeholder alignment, and how you ensured the improvement remained durable. Question 20. A senior engineer proposes a complex reliability solution. How would you evaluate it? I would start by clarifying the specific failure mode and required slow improvement. Then I would compare the proposal with simpler options, considering residual risk, operational complexity, latency, cloud cost, security, and team ownership. A sophisticated design is justified only when it materially reduces customer risk. I would ask for measurable success criteria, a failure mode analysis, and a staged proof of concept. The final choice should be explainable, testable, and maintainable by the on-call team. Be sure to mention clarifying the failure mode, comparing simpler alternatives, reliability and operational trade-offs, customer impact, cost, maintainability, testing, rollout risk, and measurable success criteria. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.